All right, cool. So 6b, long division. Thanks, guys. All right, so the first part we're going to look into is before we actually look into polynomials, I want you to write this example down, and this is just your generic process of doing a division, okay? So the example here is 13 divided by 5, and this can be read in different ways, 13 over 5, or as an improper fraction, 13 over 5. And how you will go ahead and do this process, there's different ways. Obviously, you can use logic to determine that it's 2 3/5, how many 5s go into 13. But to actually write it out, you would put it into this process like this. And this is what we usually do with, generally speaking, bigger numbers. There are labels that are associated with what number is what belongs to which category. The first one, so we have a numerator and a denominator. This denominator is called the divisor, okay? We're seeing how many 5s go into the 13. Now, it's not labeled there. The 5 is a divisor. Does anybody actually know what the name of the 13 is? It starts with the letter D as well. Yeah, correct. Dividend. All right, so the 13 is the dividend, the 5 is the divisor, and we're seeing how many times the divisor goes into the dividend. And there are two other labels. The 2 is considered the solution, okay, or the answer. But specifically speaking, when it comes to division, it has a unique name called the quotient. And you'll hear me or Miss Huffer refer to this term quotient. There is the quotient rule, which we'll look further into algebra. But this here, the solution, is the quotient. And then obviously we have the remainder, REM as a shorthand notation, and we have remainder 3. How you would read this answer is 2 plus 3/5, or you can also read it as just 2 3/5. But the reason why we include this plus is this little plus is going to be used when we do polynomial division. Okay? So this process, write down. We're going to use this process and refer to it when we do our polynomial division. Now, it is a very tedious process, and there's going to be a lot of almost arbitrary or random rules that are going to be introduced to this process. Has everybody got this down? Please say yes.
Yes.
Yes. All right, cool. So the first example, there are only 2 examples. Example 1 is we're going to look at this type of question. We want to get x squared plus 7x plus 12, and we're going to divide this by x plus 3. Now, usually speaking, if you were to see something like this prior to methods, you would think that this can't be simplified down any further. It can. There is a process where we can rewrite this specific equation, and I guess we can call it function later down the track. It can be simplified into something further down. Now, what people would usually do, and I want you to write this down, is on the side, this x squared plus 7x plus 12 can be factorized, okay? It can look like x plus 3, x plus 4. Whoops, get rid of that, there we go. X plus 3, x plus 4. So that x squared plus 7x plus 12, we have seen ways to simplify this to look like that, and this is all over x plus 3. Writing's a bit chunky, but that's all right. Now, what can we do with the x plus 3s? We can cancel them out, yeah. So that cancels out, that cancels out, and we end up with an x plus 4. Now, in the ideal world, this would be such a nice process where we can get the solution. If you have a question that looks like this, and it doesn't tell you to do polynomial long division, you would go ahead, if possible, and apply this tactic, okay? 2 lines, save time, it's really easy. But if it says, work this out and use polynomial long division, there is a tedious process that goes into this. Now, what's a divisor? First of all, out of this question, what's the divisor? Is it the top or the bottom? Numerator or denominator? Bottom, it's a divisor. The denominator, sorry. So this right here, this is our divisor, meaning the top one is the dividend. And we're seeing how many of the divisor can go into the dividend. which when writing out the first line is quite simple, but when working out, and maybe Xavier can vouch to this, is a bit of a tedious process. Yeah, there's a lot that goes into it. Okay, so let's write this out. X plus 3, and then we have that line that goes like that. Sorry if my accuracy is quite bad. Usual. It's been a while since I've done this digitally. X squared. Sorry, x squared plus 7x. Again, x squared plus 7x plus 12. Okay, here we go. This is how we approach polynomial long division. We're going to look at the leading term within the divisor. What is that leading term? X. Okay, it's just this x. And what we're going to do is, for the first step anyways, is we're going to see how many lots of just this x goes into x squared. Okay, or in other words, what is x squared divided by x? X times what gives me x squared? X times what? Yeah, x1 times what gives me x squared? Yeah, x times x. So how many x's go into x squared is just an x. With that solution, we put that on the top. Okay, so we're finding out how many of these leading terms within the divisor goes into the first leading term of the dividend. Okay, now that's our first part. The next part is then we find the multiplication of this x plus 3 into this first solution that we have here of this x. So we're taking x plus 3 and we're multiplying it by x. Right? And we'll do this term by term. What is x times x? X squared, okay? And we kind of expect this, because generally speaking, it's going to be the same as this term here. And what is 3 times x? 3x positive, 3x. So we do a plus 3x, okay? So there's our first step. All right, we've got one part of the quotient, or the answer. That's cool. Now we've got this new line. What we are going to do is we are going to subtract this second part away from this first part. So preferably in a different color. Put this in brackets and put a minus. Okay. And the second thing you're going to do is you're going to put a line underneath. Now again, a lot of these steps seem arbitrary or just kind of random or pulled out of nowhere. It will help when it comes to tricky examples. Okay, let's take this x squared and take away x squared. X squared take away x squared is 0. I mean, we kind of expect that. If you've seen this process, you kind of expect this diagonal of solutions to happen. So x squared take away x squared is 0. And what is 7x take away 4x? 7x take away 3x, rather. Yeah, 7x take away 3x. So the answer is positive 4x. Awesome. Okay. Now we can go ahead and repeat this process as well. The only problem is we've got this 4x that's just by itself. So I'm going to grab this 12 and drop it down here. All right. Now we're going to rinse and repeat. We're going to find out how many of those x's go into, so the first leading term of the divisor, how many of those go into 4x? 1, 4. How many x's go into 4x? 4. There are 4 x's. Has to be 4 of them. So that will be the second part of the quotient, plus 4. And you can kind of see, here's our x plus 4, here's our x plus 4. So we've kind of reached the final solution, but just in case, just to make sure that there are no remainders, we're done with this term. Okay, we've already completed this term. Let's take this part here and multiply it now with the positive 4. What is x times 4? 4x, we expect that. And what is 3 times 4? 12. All right. And yeah, if there is no remainder, in this case, when we do subtraction, you will get a 0. If there is no remainder, that means that this x plus 3 is a factor of x squared plus 7x plus 12. There is no remainder. There's nothing that tags along at the end. And because of that no remainder, we've got a quotient, and there's our solution. So we can say, therefore, that this x squared plus 7x plus 12 over x plus 3 is equal to x plus 4. And that kind of makes sense, because if you multiply both sides by x plus 3, you will end up getting that factorized version in the first place. So that's our solution. So again, a lot of these steps seem quite arbitrary, but it is very algorithmic. Okay, there is a process that goes on. We're going to apply it to one more example. I will just pause it so I can stop talking. All right, second example. Here we have 3x to the power of 3 minus 5x plus 5 all over x plus 2. Now there is going to be a remainder with the solution. And there's a little thing you need to consider when you're writing out the process of this long division. And it's not obvious when you first see it, because people will just go ahead and just write the process down as normal. You put your divisor, put that little line, and put your dividend. But there is a little term that we also have to include in there to make this complete, because if we don't, it's going to be really, really tricky to complete this process. So x plus 2 into, I'll put this line straight as I can, 3x to the power 3. I'm going to stop there. Are there any x squared terms there? No. But for the sake of this long division, we have to write it in. But it will be a 0x squared. Okay? Because there are 0 lots of x squared within that term there, but to put this process into practice, we have to write it there. Okay? Then we can just go ahead, write the minus 5x and the plus 5. Now that process of introducing a new term, or 0 lots of that new term, that also has to happen if the divisor doesn't have a term, or a term that cascades down. Okay, if it's missing a term, you've got to put it in there. So if it was divided by x to the power of 3 minus 1, you also have to put in the 0x squared plus 0x, and then the minus 1. Okay, so for this example, we can just go ahead and complete this process. So who remembers what the first step is? What do we have to do? Yeah, exactly. How many times the divisor, the leading term of the divisor, goes into the leading term of the dividend? So how many x's go into 3x to the power 3? And what is that solution? 3x squared. Okay, so x's into this is 3x squared. Okay, and then we multiply this divisor by this new first part of the quotient that we've figured out. X times 3x squared is 3x cubed, which is what we expect. We always expect that these two numbers will be the same. And 2 times 3x squared is 6x. All right, 6x squared, sorry. Not 6x, 3, yep. 6x squared. So now you can see that why we need that 0x squared there. We need that there so we can go ahead and continue the process. What do we do with this section here? We are subtracting them. We're subtracting this bottom one from the top one. This will be 0, and 0x squared take away 6x squared will give me negative 6x squared. All right, what is my next step? Drop them down. Now, are we dropping down the minus 5x plus 5, or just the minus 5x? Just the minus 5x. And the reason why is because we always drop down one less of how many terms there are in the divisor. We can drop both of them down. There are no repercussions per se from it. But for the sake of simplicity, we just need to drop just this one term down, which is this minus 5x here. Is this starting to ring a bell for those students who did attempt this last year? Yep. Okay, cool. All right. Now, what do we do next? How many something goes into something? What do we do? 6x squared or minus 6x squared? Okay, so the next part is we rinse and repeat. We're going to find out now how many of this leading term goes into this new term here, minus 6x squared. So x is into minus 6x squared in this case is minus 6x. Yep. Okay, so we have minus 6x. So we've got the second part of our quotient. And then we go ahead and we just multiply this term here, the divisor, with this new minus 6x. We are done with this. Usually you see me, some teachers tend to do it, I tend to do it, other teachers don't. I put a tick over the quotient of the first part because I've indicated that I've completed that multiplication process. Sometimes it can get a bit confusing which one you have to do next. So I just put that little tick there. I'm now dealing with the minus 6x here. X multiplied by minus 6x gives me minus 6x squared. Again, what we expect, so these two need to be the same. And positive 2 times minus 6x gives me then minus 12x. Okay. So again, the process, while tedious, it's always going to be the same. The only thing that changes are the numbers and sometimes the leading terms of what you have. We go ahead and complete this subtraction. And even though this is a subtraction and there are two negatives, this will be minus 6x squared take away minus 6x squared. Those two minuses will turn into a plus. So it will be minus 6x squared plus 6x squared, which gives me 0. And minus 5x minus 12x gives me 7x, positive 7x. Okay, so be wary of the signs, be careful. All right, last step, drop down. This will be the last drop down. There's a little arrow there. Last drop down, we have a plus 5. Then we go ahead and we figure out how many of this leading term in the divisor goes into 7x. How many x's go into 7x? 7. So plus 7. So our quotient part is complete. And then we go ahead and multiply this by the last one. So a little tick to indicate we're done with this one. X times 7 is 7x. 2 times 7 is positive 14. I'm just going to scroll down a little bit. Here we go. Do your subtraction and see what we get as our remainder. 7x take away 7x is 0. 5 take away 14 gives me negative 9. So there is our remainder, negative 9. We can't proceed with that process anymore. This right here is our remainder. And how we will write the solution is therefore the 3x to the power 3 minus 5x plus 5 all over x plus 2 is equal to. Now I want you guys to be really careful with this approach because a lot of people, when they first get introduced to this, will look at the minus 9 as a remainder and just have it tag along at the end, which is true, but there's something that you have to put with it as well because it is a remainder. So this is equal to 3x squared. So this was our quotient that we got at the top, minus 6x plus 7. I'll put this in a different color. Minus 9. Now, do I just leave it like that? Over x plus 2. Okay, so remember in the very first example with the fraction, whenever you have a remainder, you have to put that remainder over the divisor. Okay, so in that case it was what, 3 over 5? It was 2 plus 3 over 5. This is my remainder, the 9, over the divisor, x plus 2. Please don't get into the habit of just writing a minus 9, okay, because that is incorrect. Because if it was that, you can then simplify 7 with the minus 9, which will give you a completely different answer. Okay. All right, that is the process. I'm going to finish recording